Hello, everyone. Welcome to NYC Builds Bio webinar entitled A Primer on Lab Facilities and Related Cost Considerations. Thanks so much for joining us this afternoon. My name is Nancy Kelly, and I serve on the steering committee and as a founding member of NYC Builds Bio. First, I'd like to acknowledge and thank the founding and corporate members of NYC Builds Bio who make all of our programming possible. Today, we have 5 organizations who are sponsoring this seminar: BAM Creative, Millrose Consultants, Skanska, WSP, and Safety Partners. We thank them for designing this seminar with such a wealth of information to inform all of you about building and renovating lab facilities. BAM Creative is a full-service, multidisciplinary design agency providing first-to-market design solutions on technically complex projects for leading organizations. Millrose Consultants provides mission-critical compliance consulting services to Class A commercial real estate market through its diverse portfolio of permitting, code and zoning, regulatory filing, due diligence, and other compliance solutions. Skanska is a world-leading project development and construction group building for a better society. WSP creates creative, comprehensive, and sustainable engineering solutions for a future where society can thrive. Safety Partners offers a rich array of environmental health and safety services for life science companies. In this seminar, our speakers will share the basic understandings necessary to develop a successful laboratory facility and the unique cost drivers behind delivering value and quality. I hope you all had a chance to review the excellent white papers from BAM Creative, WSP, and Skanska, which contain detailed summaries of the information we will present today. If you haven't, please take a look after the seminar. Our speakers today include Susan Rosenthal, Senior Vice President, Life Sciences and Healthcare, New York City Economic Development Corporation; David Stockel, Senior Vice President, CBRE; Daniel Kastner, Principal, BAM Creative; Trevor Bowes, Vice President, WSP; John Tamburino, Vice President of Pre-Construction, Skanska; Joseph Del Pazzo, Senior Vice President, WSP; Gustavo Mazza, Executive Vice President, Life Sciences, Millrose Consultants; Yasmin Ahmed Patti, Principal, East Egg Management; Brian Northrup, Executive Vice President, General Manager, Executive Advisor, Science and Technology Advisory Council, Skanska; Ray Moore, Quality Research and Training Specialist, Safety Partners; and Karen Heidelberger, Partner, Deerfield Management. Welcome, everyone, and thank you for joining us today. This webinar is part of an ongoing series of online events hosted by NYC Builds Bio. You can view the series on the events page of the NYC Builds Bio website. Please register for our future monthly webinars in June and July. On June 17th, Taconic Investment Partners will offer virtual tours of the Hudson Research Center and the West End campus, a 3.4-acre assemblage on Manhattan's Upper West Side meant for state-of-the-art, purpose-built research and laboratory space. In July, our member spotlight shines on Boston Properties, one of our new members who will share with us their extensive life science portfolio and plans for New York City. Also in July, C16 Biosciences will talk to us about their move from NYU Biolabs to 19,000 square feet of R&D space at the Hudson Research Center. We will be announcing in-person tours of new developments commencing in October with Deerfield Management's 345 Park Avenue South called The Cure. A date will be announced for that event shortly. We hope that you will join us for all of this rich programming. Before I begin, I want to offer a few administrative details. There's a program and PowerPoint highlighting the hosts and speakers for the meeting. These will be posted on the NYC Builds Bio website. The program is being recorded and will be distributed to all registrants after the meeting. If anyone's having technical difficulties accessing the Zoom room or other technical issues, please email info@nycbuildsbio.org or send a notice through the chat button at the bottom of your screen. Since most of you are participating in listen-only mode, please feel free to submit your questions via the Q&A button at the bottom of your screen. We will open up for discussion and Q&A at the end of the program and will address as many audience questions as possible. At the end of the meeting, we will also have a chance for smaller randomized groups to meet in separate rooms where you can open your videos and microphones to talk to each other. You can stay as long as you like to get to know each other and share stories. Now I will open it up to Susan Rosenthal and David Stockel, who will open the seminar with a discussion on the ever-changing life sciences landscape.
Thanks, Nancy. Nice to see everyone. So I think the latest that I'm excited to report on is that there's continued fantastic momentum in the life sciences real estate sector in New York City. Thought I'd maybe just review a couple high-level points, then I'll turn it over to Sue to continue. Funding continues to grow at a rapid rate for New York City companies. The first quarter of 2021 was actually the best ever, reaching almost $400 million in venture capital funding.
Yeah.
As many of you probably read in the press, NIH funding is expected to grow by potentially over 20% next year, which would be the largest percentage increase on record in many recent years. Leasing velocity, we've actually already surpassed all of last year in just the first quarter and a half or so alone of this year, led by Mount Sinai's lease, which I'm sure many of you read about in the press, of 787 11th Avenue. One of the other great stories that continues to gain momentum in New York City is the continued graduation space leases that are getting signed by many companies who are graduating out of New York City incubators. Many companies born and bred in New York City, which is great to see them growing here and staying here and creating jobs. A couple in particular actually signed a lease at 345 Park Avenue South at Deerfield's building, which is fantastic news, and another one that I think Nancy referenced earlier over at Hudson Research Center. And then the other last point I'd make is we're starting to see many more large occupiers of lab space entering the market and looking around the market for larger blocks of space, which is showing the continued development of the market overall, which is a really exciting point. So I'll stop there and turn it over to Sue.
Thanks so much, David. Good afternoon, everyone. Thank you for having me join today. Nancy, thank you so much. Just so I think I'm new to some folks, and if you're not familiar, EDC is the place for New York City as part of the city infrastructure to help build industries, to help build neighborhoods, and to create great quality jobs for all New Yorkers. And part of that is with life sciences, knowing there's great opportunity for this industry in New York City. And so I'm going to share my perspective on the industry in the city today. And that really has to start with where we are, given the pandemic that we've all been through and continue to go through as part of the city. And we've certainly been through a really tough year and then some, and one that was painful for many, and one that we can very proudly say as an industry really led to us stepping up across the board. Before the pandemic, we were already seeing significant growth in New York City's life sciences market. And in the beginning of COVID, I think I can probably speak for many of on the Zoom today and say we all took a collective breath to hold on and see and watch what might happen. And despite the awfulness that was this past year, that story of growth that was starting before the pandemic has not changed. If anything, we're seeing it more robustly than ever before. And you can look at some of the metrics that we've seen in recent reporting, whether that's through I know, David, there was a CBRE report that's been continually updated. We're seeing those metrics grow. And there was a metric from the recent Partnership for New York City report that stood out to me that continued to show growth in the funding that you mentioned earlier. And specifically, we saw that every dollar that New York's research institutions received from NIH led to a match from the venture community of 73 cents, which is more than a 5-fold increase since 2016. And that to me is a real indicator of the robustness of the activity with our startup community and through the venture community, a measure of growth that we see continuing to go on that upward trajectory and even inflect more strongly. And if you had asked many of us 10 years ago to name New York City life sciences companies, we'd probably struggle to come up with a handful. And now when you look into the research, we see we're in the hundreds. We've grown to 6 fantastic incubators with some additional ones on the way. We know, for example, I know Karen is on one of the panels today. We have a medtech incubator with Corridea that was recently announced at the Cure with Deerfield. And whether from those incubators or otherwise, we're also seeing great success stories start to come out of those incubators in both number and size for companies that are reaching new financial, clinical, and size milestones. Just last week, we saw the announcement of the launch of Stablix with a $63 million Series A with Carlo Rizzuto at the helm. Immunai is another great example, which moved to biolabs when I first got to EDC a couple of years ago and recently raised $60 million and acquired a genomics company. These are the kinds of growth that we're seeing naturally happen. Another great example, Velastra Therapeutics, which came out of Lou Cantley's lab and was in J Labs, recently took space in West Harlem in the Mink building, and we see them growing. And I have to admit, they post some really cool neighborhood posts on LinkedIn and social media that I look forward to seeing more and more of every day. And in speaking with the life sciences community, we hear of many reasons to believe in New York City for life sciences. Some are very well known and familiar, so I won't take you through them. I think you're very familiar with our incredible academic and medical institutions, the access we have to markets, the capital. We are the capital of the world, and we attract investors, companies, and partnerships. We're also hearing more and more that the intersection in New York City of tech with biology is an advantage that's growing and showing itself, whether that's from companies like Flatiron or Medidata or other biotechs that we're seeing that have AI arms as part of their therapeutic platforms. We're also seeing life sciences grow in those therapeutics like we'd expect, but also in areas like hardware and diagnostics and in that evolution of biology to more sustainable products and other uses. David mentioned C16 Biosciences. They were in biolabs. They're now expanding to Hudson Research Center, sorry. They make a synthetic palm oil, and that is not a traditional product in life sciences, but is an example of a segment that's growing within biology and within New York City. Similar, we've seen growth on companies with robotics or other tech-enabled hardware. And Opentrons is a great example of that, based out of Brooklyn, that actually helped us in this past year as we were facing this pandemic and helped us open the Pandemic Response Lab, which essentially ensured testing in New York City was available to anyone with under 24-hour turnaround time, and has since expanded into genomic surveillance. I could probably speak for another hour on those success stories. I could mention a great growing list of companies, whether that's Calliope or Black Diamond or Schrodinger, Envisagenics, Miramis. We know there's just a lot happening. And we also know that larger pharma and biotech companies have started to consider New York City for options. And we're thrilled about that. And we heavily welcome that as a city. And if you are engaging with any of them, would welcome engaging with us to talk about that as well. So, we know of over 2 million square feet that's coming online in the next couple of years. And we're getting asked more and more by developers about life sciences in New York City, partly because of the market dynamics that we saw in this past year, and partly because of the growth trajectory that we know we're on. And we're not there yet. We're not at critical mass. That's one of the main reasons we continue to put forward investments like the Life Sci NYC investment that we launched in 2016. And we continue to support getting there through our city's various financial support programs. We know New York City is also a very specific place. It's not for everyone, but we know it's for many. And we know it's certainly what it promises. And one thing that we've heard from the community is that with respect to emerging science and technology, the culture, the talent, you find that here, that is a continued strength for us to rely on. But we also, when we think about the talent, we make things happen. And that stands apart to investors. That really stands apart to the life sciences community that have chosen to stay here, chosen to grow here, and chosen to expand. And I'll share that one of the VCs that we recently spoke with said it well. essentially saying that when you hire in New York City, you know you'll get great talent that delivers at 200% because they're hungry for it. And whether that's in Manhattan or in more traditional neighborhoods like Hudson Square, Long Island City, Brooklyn, or up near Morris Avenue in the Bronx, we know that New Yorkers are hungry to grow in life sciences. And so thinking to managing my time, I know we have a lot to cover. You can see I'm very passionate about New York City and what we have to offer for life sciences. Somewhat like that investor was saying, we as a city are hungry for it, and we're excited to bring it to fruition with you. And so with that, Nancy, I'll hand it back to you to segue back to the next agenda topic.
Yeah, thank you, Susan and David. You know, I was saying on our prep call that it's so wonderful to see the community have grown to this extent over the last several years. And just reflecting back on when we had our first life science real estate symposium in 2018, we only had 2 projects to talk about, the New York Genome Center and the New York Stem Cell Foundation. And now we've got, you know, buildings and developments going on in every subcluster across the city, which is really quite extraordinary and exciting, and really due to the EGC's efforts to really promote this industry. And we hope that continues as we move forward post-pandemic to regain our economic health in the city.
Thank you, Nancy. I could say the same to you. You're one of the founders of this ecosystem. Thank you.
Okay, well, now we get to dive into the white papers, which I hope you've all had a chance to take a look at. So Daniel Kastner and Trevor Bowes are going to speak, as well as John Tamburino, to both of those papers.
Thanks, Nancy. So first, I just want to reintroduce the team. I'm Dan Kastner with BAM Creative. Trevor, John?
I'm Trevor Bowes with WSP.
John Tamburino, Wisconsin. How you doing?
So we're all here today. Thanks, John. We're all here today. Really, it's a converging interests of the current economy, the pandemic, the soft commercial market. There's been a ton of interest, as Susan had mentioned before, in particular with developers looking to take their space, either build new space or convert existing space to life science. We've all been fielding a lot of questions lately from the life science perspective, as a lot of people just don't have the knowledge, but they have the desire to learn. And so from that, Trevor and I basically began to write a paper to kind of address these questions, understanding that developers are ultimately looking to pivot to and looking at their assets and trying to figure out, okay, what space can we convert to life science? What makes the most sense? So we were, in fielding those questions, we decided it would be really helpful if we could provide some sort of guidance from a design perspective, architectural and MEP. And then in talking to John and his team at Skanska, they had the same realization that it would be really helpful from a cost and construction perspective as well, looking at really what are the drivers in terms of starting a lab. So if we want to start with the first slide, we're going to give you a little snippet into the research paper. We'd love for you to, if you haven't read it, feel free to take a look. This is one example of a page where we're providing the perspective comparing a commercial office situation to a laboratory building. In a lot of cases, people have come to us and said, hey, we have this space, it's in Midtown or it's downtown, it's in Long Island City, we want to convert it to lab. What do you think? Do you think we can do it? And so this looks at several different aspects of it, including floor-to-floor height, ultimately column spacing, and the importance of certain types of infrastructure, things that we feel are really important for the developer to understand if their building is suitable for that situation. Ultimately, go ahead, Trevor.
Just to add to that, we realize every building's different, every lab program's a little bit different. So this is really supposed to provide just a guideline, a snapshot look at how far is that existing building from to where it needs to go to bridge some of the life science needs.
Exactly. So yeah, none of these are hard requirements, but they're really guidelines. For example, if you don't have 17 feet or 16 feet, we can still probably work with you on it, but that's really where that kind of sweet spot is for a floor-to-floor, for example. So let's go to the next slide if you don't mind. So this slide kind of really looks at the ideal lab situation from a plan and also from a sectional perspective, talking about, for example, column spacing. I mentioned column spacing before. The importance of an 11-foot lab module leads to a column spacing of 22 or 33 feet. That's kind of important in order to create some really strong efficiency of a lab type space in another type of environment. The importance of lab equipment, for example, as well. Understanding that a space is going to have a heavy load, and some of this equipment might be relatively tall, so you have to consider that when you're planning out a space in the plan option, as well as considering that the lab proper, the wet lab space itself, might only be a small portion of the overall footprint of what the tenant is going to need. There's going to be a significant demand for lab support rooms and very specialized type rooms, as well as the dry lab space as well. And then in addition to that, you really need to also consider the section, the floor to floor that I mentioned before, the 17-foot. What's above that ceiling? What drives that really high 16 to 17? And that's ultimately the mechanicals. On the left side here, you see an actual project giving an example of the mechanical space that additional air requirement for a lab space really stretches that plenum space out in terms of what we need to fit in. And on the right side, you see kind of the different zones that are required to provide everything that's needed for a lab type space.
And a picture is worth 1,000 words. As Dan mentioned with the section, you could see the difficulty of the surfaces that are in there, and the importance it is to create the horizontal and vertical pathways for both the day one and the day two services. The white papers that we developed go into this in detail, and these are just some examples illustrated to prove the point.
Exactly. If we go to the next slide, please. Lastly, another consideration when you're looking at square footages, which we'll talk about later in the next panel as well, is understanding that if you're dealing with a multi-tenant space with regards to lab, you're going to not only consider amenity type spaces, common elements that you might provide in a typical office building, but you're also going to have to consider lab amenity spaces as well. Some of these types of spaces could be glass wash and autoclave and microscopy and a freezer farm. Some of these spaces, if you think about a tenant coming out of a incubator type space, they may be used to this type of environment being provided for them, but if they're looking to go out on their own, they may still be interested in sharing that with another tenant. So you have to consider as a developer, is that something that you want to consider providing, hiring someone else to provide those services, or is the tenant going to provide those services? Ultimately, thinking about zoning on the floor and where a lab for one tenant might be efficient to have all of those labs in a somewhat similar section of the building, and also considering the zoning in terms of the exhaust, having all of that exhaust being sent up to the roof of the building. Where does that exhaust lie? Having the short routes from the labs to a potential shaft area, and then also looking at the zoning for electrical as well, as Trevor.
Exactly, and metering and vertical distribution as well as horizontal distribution, where you may have floor plates that are going to change over time. The example that we're showing here is a floor plate that could be single tenant, or it could be broken up into 4 distinct different tenants with the capabilities to have that metering in place and provisions to bring any specialty services up to mechanical or roof space. So those are the types of things that are important in multi-tenant lab design that developers should consider when building a space.
So we'll send it over to John if you want to continue the discussion with the next slide, looking at the cost side of things.
Our white paper was derived from a big need from our clients wanting to fully understand what the costs are for fitting out a lab. So we developed this white paper in order to have them better informed and better understand how they're going to spend their money. So there's 5 major cost drivers within a lab space. Obviously HVAC systems, plumbing systems, electrical systems, lab architecture, and lab equipment and casework. I'll touch on each one of these very briefly, but there's more in-depth descriptions of it in the white paper itself. So HVAC systems generally in a lab versus an office, first off, we're looking at only wet labs versus dry labs right now. Dry labs are more computational in nature than rather than wet labs. So the cost analysis is derived from wet labs. On the HVAC systems themselves, there's a lot more air coming through the space in a lab space versus an office space. Whereas in office space, the air gets returned back to the AHUs, and HVAC space for the labs, all the air gets exhausted out to the outside air, which also includes some specialty filtration systems as well. Plumbing systems, they have numerous types of different systems in the plumbing, such as water systems, like the ionized water, specialty piping, like polypropylene piping, and also lab gases themselves. All these are major costs to the lab fit out. Electrical systems have enhanced power distribution systems, as Trevor just explained in his talk. And then the lab architecture briefly is about the overall height of floor to floor, as Dan mentioned. So in a lab building, the lab is 17 feet thereabouts, whereas an office space is generally around 12 to 14 at the most. So there's contrasting costs in the exterior envelope versus lab versus office, even though that the lab exterior wall will definitely offset the cost of your overall office, because there's more lab exterior wall versus the office space. So again, there's other things to look at there, but generally that's where that sits. And also on the structure itself, the structure is a little bit more stiffer than an office space to control vibration and movement. On the lab equipment and casework, obviously the office spaces do not have any type of lab fit out casework in their spaces, whereas the lab equipment has varying degrees of cost in terms of movable equipment and casework, and also fume hoods and things of that nature. Next slide, please. So here we have a slide indicating range of costs for office spaces in different major marketplaces that we work in. The colors represent certain key building systems, whereas the light blue is superstructure, the dark blue is building envelope, interiors are that green, mechanical and plumbing systems are that I guess it's a mustard yellow. I'm not quite sure what color that is. And then the green itself is electrical systems. So as you can see, if you focus on New York, Boston, RTP down in North Carolina, and also Northern California. In New York, I'm just going to focus on New York for now. You can see by far the most cost system there is the HVAC systems and MEP systems themselves, fully $222 a square foot, versus the other locations. Even though you can tell each one of those locations, the mechanical systems are the most expensive piece in the whole thing. The next slide down is the dollars per square foot range of costs for office construction. These are all buildings out of the ground, by the way. So here you can see the contrast in costs for the exterior wall envelope, as I was mentioning before. The cost for the exterior wall in New York is out of the charts. Boston, same way. So is Northern California. You can see the difference in cost for the exterior wall, whereas all the MEP systems are generally around the same cost, dollars per square foot wise. It's important to understand that these building costs are out of the ground. So when we look at square foot numbers and fit out costs, the ranges of costs can be anywhere from, on the high end, almost $700 versus the low end, $350. And also when you're considering fit out costs in existing buildings, there could be additional costs for infrastructure upgrades, which can vary in costs from anywhere from $95 to $180 a square foot. And then the last piece would be an enhanced infrastructure upgrades, whereas you might have a building that has to have new windows put in, or the structure might have to be modified in order to accommodate the lab spaces. So all those things have to be taken into consideration when you're looking at a space to fit out. Next slide, please. This last slide is a Skanska metric snapshot of our benchmarking database. It's used by our company across the US in order to crunch numbers to make sure that the numbers that we give to our clients are within the range of other projects of similar size and scope. Here is an example of 5 life sciences projects across the US. We give a lot of information on these things. You can see in the box there that $505 a square foot is an average cost of all those 5 projects listed there. We can also adjust this by location and also by current quarter or future quarters. So escalation factors can be adjusted here as well. The last piece on the bottom there is the distribution percentages of the program, which is very important for us and for you, and of course the designers, to understand how much percentage-wise the different programs are. You can see in the blue there, that dark blue, that is the wet labs. And by far the wet labs are the most cost dollars in any fit out space in anything that we do. And before I get off of this piece here, there's one last piece that we at Skanska publish on a quarterly basis called Skanska Market Trends. As many of you may be aware, that there's been a big increase in costs for materials across the US. It's outrageous, really. So in our quarterly report, we see that the overall construction index is up by 1.1% over the last quarter. When I look at the costs for, say, steel over the last quarter, the costs are up 19% over last quarter versus today. This is only a first quarter report. Our second quarter report comes out in July. Plywood, as many might be aware, plywood is up by 12.8% from last quarter to now. So all these things have to be factored into any cost that we give to any client. It's important to stay ahead of these things, and we try to keep abreast by publishing these market trends reports. And I'll give it back to Nancy.
Yeah, so John, I'm noticing that of all the projects that you cited there, most of them were academic institutions. Is there any difference between an academic institution and a commercial life science build out?
There are subtle differences, yes. Some of the commercial type lab spaces can include specialty spaces like vivariums and BSL labs. A lot of academic institutions include vivariums as well, but there are subtle differences, but not that much if they're in the same program.
Okay, we had a couple of questions. Someone was wondering how the white papers can be accessed, and basically there are links to both of them on the invites that have been continuously sent around before the meeting. So if you look at the top of the invite, the names of both papers are listed there, and you can click on them, and that brings you to a PDF of the paper. They're also attached to the NYC Builds Bio website, so you can download them from there. And then Mark Rosenberg is asking, what are the incremental costs of a life science tower over Class A office?
So if you looked at our slide, the first slide I put up there, lab versus offices. So I know in New York that we're building a huge lab for PHL, Public Health Lab, and it's quite expensive based on the programs there. I can tell you that cost of that project is much more than a Class A office space. I can tell you that right now. Class A office spaces can go anywhere from $900 to $1,200 a square foot. Lab spaces like that are above $1,500 out of the ground.
Okay, great, thank you. So now we'll turn to Joe Del Pozo. He'll lead a discussion on how to evaluate where to build or renovate in the city.
Thank you, Nancy. So building upon some of the talking points you've already heard in the white papers, with that in mind, the developers are interested where to build, and should renovations be the one of the key avenues to develop a space. So we've got a panel here assembled, and I'll have them all introduce themselves. I'll start off with Yasmin, and we'll go to Dan, Trevor, and then Gus. So Yasmin.
Great, thanks. Hi, I'm Yasmin Ahmed Patty. As Nancy said, I'm the principal of East Egg Project Management. My background's in real estate and economic development. I've been doing this work for about 18 years, starting with when I met Nancy all those many years ago. And it's great to be here. Thank you.
Thanks, Joe. Dan Kastner with BAM Creative, principal and registered architect. Also science and technology practice leader for the office. I'll be the next president of IFMA New York City. And I've been working in labs for about 20 years. And Trevor and I, for the record, have been working together probably about almost 15 years at this point.
Yeah, that's
Trevor.
correct. Thanks, Dan. My name is Trevor Boz. I'm a vice president with WSP Building Systems. So we do mechanical, electrical, plumbing design based out of New York City here. I've been doing science and technology or laboratory design for about 15 years with developer and pharmaceutical and institutional based projects.
Hi, my name is Gus Mazza with Milrose Consultants. I'm the executive vice president in life sciences here at Milrose, and my task at Milrose is to grow the life science sector nationally. And what we focus on is building code and zoning consultation and permanent expediting across the United States.
Okay, great, thanks everybody. So let's jump right to Yasmin. And from the developer's lens, who are the life science tenants that the developers are targeting, and what are the tenants looking for? And are there any specific common trends that the tenants are seeking? And I'll just keep piling on. Are there any specifics in terms of proximity to certain academic, healthcare institutions, neighborhoods, et cetera?
Sure. Well, there's, I guess it was a lot of questions, but
Yeah.
I think the developers, developers want to see if they can, what they can do with their buildings. And as we talked about before, as Dan talked about before, the zoning, the types of buildings, right? So those are the factors about the bones of the building and what, where we start. I think we want to be where the tenants want to be, where they can attract talent, where they can offer amenities. Initially, when we started this whole life sciences sort of sector, this whole idea in New York, we did want to start where on the east side, because we wanted to be near the universities, right? So that whole alley along First Avenue, we wanted to be near the universities. Historically, in other markets, the startups wanted to be near the universities where they spun out from. But what we've been finding, as I think the life sciences just as a sector grows, and here in New York, we're growing in different spots around the city. I think one, because unlike other parts of the country, unlike other markets, New York, and I've said this before, we do have this great transportation system, right? So it's relatively easy to get from place to place in New York. So that's one. I think two, what we are also finding, I did the Long Island City partnership study on life sciences, feasibility of life sciences development over in Queens. And in interviewing companies, we really found that being next to the university isn't quite so important for everyone. It's not sort of the main top priority. It's helpful if you need to do the lab work there, if you need access to the vivarium there, other researchers that are still on campus. Those are the companies that need to be near the universities. Other than that, they want to be where other companies are. They want to be where the restaurants and bars are. They want to be where they can, get to on the train. So things like that. That's in terms of location, that's where they're looking.
And Dan, perhaps, are you seeing any specifics in terms of trends from what needs?
Yeah, I think everything that I agree with everything Yasmin was saying. Once you have a smart location that and in New York City, there's plenty of actually smart locations because of our density and the amount of institutions in the area. But after that, you're looking at a space that is that is inspiring. If you can draw people with a really great space, but at the same time, you have to think about practicality. I think a lot of scientists who might be getting into this realm and starting to think about real estate are more interested in does the space fit the needs of the floor to floor, the equipment that I have, will my equipment fit in? Understanding that I might need flexibility. I'm probably growing. I might be this size, but I'm going to tomorrow or a year from now, I might be significantly larger. So making sure that the space, the casework is flexible. There's going to be ultimately need to be a balance between an inspiring space that has lots of transparency and light, as you see in a lot of the renderings, and as we talk about spaces that are opening up in the city, but balancing that with the practicality of very large pieces of equipment and the need for some fixed infrastructure. So there's going to be a balance between the two, and if you can serve both needs, I think you have a great space to start with.
Thanks, Dan. And maybe Yasmin, back to you. Are there any specific types of labs that the graduates are looking for, and can you elaborate on that?
Yeah, I do want to repeat agree with Dan about what he said in terms of attracting talent to the particular spaces, in terms of them being inspiring. I remember, Nancy, you remember Nico over at the Genome Center, when we finished our labs, he was walking a bunch of scientists around. These were these brand new labs, I guess 2012, 2013, and came over to my desk and said, Yasmin, this is the greatest space. Like, you will have anyone who walks through here will want to work here because of the space, right? So I think that's, Dan and the other architects have their work cut out for them, because it's really an important factor. I think to your question, Joe, I'm sorry, repeat the question. I'm so sorry.
Yeah, no. Are there any specific types of labs that the graduates are looking for? Any specialties?
Yeah, well, it certainly depends on the size and what they're doing. What I'm finding when I talk to the many companies that I talk to, there's a range, right? There are companies that get the $85 million, $60 million, huge funding rounds, and they can move into 19,000 square feet, and they can hire 20 people at a time, which is fantastic. What also happens, though, is companies that maybe get a little seed round or get $4 million here and there, and it's a little harder for them to get such a big space. So one thing that I still think we are looking for in New York are the immediately post incubator. So I'm a company, I'm 4 people, I get a little seed round, I can grow to 8 people maybe, and so I need 3,000 square feet of space, right? I can't afford, nor can I occupy a larger space like the ones that are out there right now. So that is one thing that I do think we're missing on a smaller scale, but so it could be any range. Okay. And I think, again, to Dan's point about flexibility is also really important, because you just never know. I can't tell you how many companies have we started out doing this and then something happened and now we're doing that, right? So the science has to, or the space has to accommodate that. Otherwise it gets more expensive.
Right, thanks. Maybe Dan, hypothetical question, speed to market a key driver, and if a developer came to you with 2 options, one, an empty lot ready to build something, or an existing building that they're considering renovating into a life science building. How do you advise them? What are your thoughts?
Yeah, I think not every building is well suited for a laboratory. So before you get too far, you have to really look at some of the key things about an existing building. The floor loading we mentioned before. John had mentioned the vibration, an issue, highly sensitive issue for microscopy and certain instruments for research. The column bays I had alluded to before. Ideally, you've got like a 22-foot column bay roughly, or 33. Either one really would work with an 11-foot lab module. Floor to floor heights are really critical. But in addition to those 3 things, you really need to consider the loading aspect, the deliveries. A lab is going to require a lot of things coming in and going out, and you really need that loading dock and freight elevator, significant freight elevator, and ultimately you got to think about what's in the basement. Is there enough room for acid neutralization, for example, and how far up is the roof? You have to consider that each floor of a lab space is going to need to be exhausted separately. So every time you have a floor of a lab, you're going to have another shaft that's going to have to go somewhere. So these are all things you have to consider with an existing building, and ultimately, when they all add up, you have to decide, okay, does it make more sense to start out of the ground, or is if this building is not too high up and does have check all those boxes, then it makes sense to utilize it.
And Trevor, similar question to you, and how does that impact the MEP systems?
Absolutely. Well, we just heard from John how expensive the mechanical and electrical systems are in a building, and they're a big driver to the cost of the laboratory infrastructure. And it needs to be factored into the overall cost of the project. Converting from an existing building, whether it's office or some other non-industrial type, it's going to be expected that upgrades are going to be required. It's key to understand whether that's going to be as easy as adding on to an existing chiller plant or boiler plant, and expanding it that way, or whether there's no space for it and larger upgrades need to be considered. In addition to that, the distribution challenges, getting ducts and pipes and services up and down the building through spaces, that should be looked at. And as the earlier you're able to identify how easy or difficult or feasible it is to do that, the easier an owner is going to be able to make a decision on whether it makes financial sense to move forward with that site or not.
Great. And Dan, maybe back to you. In a pre-built condition, what's going to entice an incubator that's ready to step out, and what will entice them to come to your building? And do these folks actually know their day one needs and future needs as well?
Yeah, I mean, a pre-built situation is ideal so that they can move in quickly, for sure. And then understanding that from the beginning, there's definitely certain things that we know as designers that we can kind of replicate in labs. That's common. For example, knowing, that lab support is really critical. Having specialty spaces, not just an open lab with lots of transparency, but you're going to need individual rooms. You're probably going to need a fume hood, and you're going to probably need some sort of potentially you might need some self-culture, and so you have to think about piping for CO2 or any other gases. So those things you have to decide early on if you think it's worth it to spend the money. That's going to be pretty common in most programs. To be able to convert the space quickly is key, and we've seen that with tenants who take a space and there's really not a lot of requirements in terms of changes because those common denominator senses of program were addressed early on, if in a pre-built situation, for example.
Great. And Trevor, based on Dan's assessment, similarly, the MEP needs and infrastructure are complex and need to be fully understood by the developers. Can you speak a bit about how much infrastructure to install day one and potential provisions for future modular expansion as the building occupancy increases?
Absolutely, and I think the answer to that really depends on whether it's single known tenant up front or whether the building's being built more on a spec basis where there could be multiple smaller tenants and that need's not fully known. From an infrastructure standpoint, the incoming utilities, you want to size that for the future use of the building. It's going to be extremely disruptive to go in, upgrade electrical services, gas services and things like that later on. So from that standpoint, incoming utilities should be sized for the entire building. If it's a known tenant, again, you're best off sizing it appropriately for the needs of the tenant. And on the spec basis, modular is a great way to go. You could have a base size chiller plant with space and capacity to modularly expand it. All the duct mains and piping mains, things of that nature should be sized for that larger future use to avoid rework in the future.
Okay, great. And Gus, can you speak a bit about some of the benefits or obstacles to reposition an existing property versus a new building? And is the pathway to occupancy easier with repositioning?
Sure. Joe. So what Dan and Trevor talked about earlier was the early on due diligence of determining the location of the existing building. When we get brought in by an owner, they wanted to know if they could add labs, any type of life sciences. So we do, a high level due diligence. We look at the zoning to determine obvious what kind of zoning use group you're permitted to have as far as the type of lab. And it's important because before Trevor and Dan get into getting into all the detail, the zoning is critical to really establish the type of lab and what the needs are that the owner is trying to develop, whether it's a new building or it's an existing positioning, whether it's wants to create startups or pre-built labs with the flexibility to draw in bigger labs or a graduation space from that. So that's a discussion that we all need to have early on to determine what kind of client they're going to be catering to. Obviously, with an existing building, you reposition, the building's already built, the infrastructure is there and is being modified or added to or changed. The C of O is already there, and we're just modifying the floor as we need to, or parts of the floor. So the turnover into construction to occupancy is much quicker than when you're doing a new building where you have to get the obvious core and shell completed and all the systems completed before anybody can tie in. So again, it's speed to market. So if you have a building repositioning and it's existing, and obviously if Dan and Trevor make it work, then yeah, an existing building would always give you a quicker path to occupancy.
Maybe as a follow-up, are there any early permitting strategies available today that can allow construction schedules to be compressed?
Sure. There's opportunities to start doing infrastructure work regardless of what the building is for. The actual work that pertains to the lab, for the actual lab usage would need to be reviewed thoroughly because it would be a change in occupancy, but there's nothing to prevent an owner to start building things up. The code is there as a minimum requirement. You could always build to exceed the requirements of the code and then later apply it to the tenant. So yeah, there's opportunities where you could start work. Obviously, if things change later on, you have a more robust system. You have a better rated floor slab. So those are things that you're not going to lose. They're going to be overbuilt, but there's opportunities there to start earlier if you see the opportunity to bring a life science.
Okay, thanks. And both Dan and Trevor, maybe Trevor, go first. From a design perspective, are there also any strategies to accelerate or help with the construction schedule?
Yeah, absolutely. We've been seeing more of a trend towards prefabrication in New York City and elsewhere. It's been common for a while to do prefabricated mechanical rooms, boiler plants, heat transfer skids. So that's a definite opportunity that reduces lead time, and that could even be taken a step further, particularly if there's a repetitive type construction and there's enough ceiling space where we could still route surfaces around. You can even prefabricate sections of piping manifolds and ductwork to speed up installation.
Yeah, and you can also consider for the lab casework modularity. I know in some cases we were talking the other day about right now resin being the tops for the casework being a long lead lately because of recent events in Texas with their climate issues, and those things aren't going to go away. So we see both modularity and buying off the shelf and pre-purchasing items that we've never had to pre-purchase before, but becoming more and more regular way of working. Obviously, there's a risk there because you're kind of building things before you're designing them, so you have to kind of balance between the places where it's most modular and where you can easily replicate, and then there might be a few customized areas where you have to rely on the standard method to get everything you need for the project.
Okay, thanks, guys. And Yasmin, maybe back to you. And the front end of a space search, how far ahead are your clients thinking about new graduation space, and are you finding it difficult to secure available space? They're giving you enough time to find that space?
Right. I guess it does depend. I know many companies, and it's been written about, and people talk about the idea that you get funding on a Tuesday and you need your space on a Wednesday, right? So it's just, they really, because once they get that funding, the work really has to start. It really has to pick up. Given that that's not possible, it depends on, again, what they need done with their space. If they can get it a little bit more pre-built, a little more generic, maybe. I think, for example, Velastra took advantage of a great situation where, Quintus built out the space, wasn't able to move in, but that was to Velastra's benefit, which is really, really great, right? They just plug and play sort of thing. So to Dan's earlier point, I think the more we have of that, I think the better. And then there's that range. I mean, I don't know, 6 months, 9 months. I think we did the Genome Center, not including design, but we did the work in 9 months. And I want to say that Quintus Space was around that time as well. So it just depends on how much work you have. I think the earlier tenants start thinking about it, right? Like we haven't closed our Series A or our, SPAC or whatever it is yet, but we are on track to do so. So let's do this real estate search at the same time. I think that's the best way to do it. I think to look at all of the projects that we've got here existing, we've got InnoLabs, we've got the Alexandria spaces, we've got the Deerfield space, we've got, as opposed to a couple of years ago, to Susan's point, we didn't have all these spaces sort of open and ready to go, and now we do, which is fantastic.
Right.
So that makes things easier as well.
Yeah, I just want to add to that that I think it's also important to recognize the way people work has changed, and so now is the time, as we're doing new spec labs, to consider the need for collaboration. There's definitely universal concepts with regards to lab planning, but then how people work in the open, the dry lab portion is also critical, I think, as well. To consider more collaboration space is going to be critical now that a lot of people are working hybrid. That's not necessarily the case in the lab, but even there, I think collaboration is key. You have so many different. You saw with the virus vaccine as well, the cross collaboration of a lot of different entities, and without the technology and the good acoustics and lots of good space to be able to do these types of Zoom conferences is really important for the future of research.
So Joe, this has been a great discussion, and I think we've got a few questions here, and then we've got to move to the next panel because I just want to be respectful of time. So Regal Diaz asks, do you see a benefit opportunity for design-build approach for the life science market?
Well, maybe I'll answer that one. I'll take a shot at it. It's definitely an opportunity. One of the things we find is that a lot of the design information might come a little later in design, and when a design builder wants to start building, we might not have all the information that's needed. So it needs to be an active discussion about all the needs of the project and programming of the project to make certain that the design keeps up with the construction, and the construction can be paced accordingly.
And then we've got a question, are tenants asking for, or are developers adding amenities such as green space at street level or on roofs?
Maybe Dan?
Yeah, no, that's important. It's very important. With regards to most developers, we've always introduced a concept of some sort of collaborative space, whether it's a rooftop type environment or a street. It depends on the situation and where you're located. In Manhattan, for example, in Midtown, where the zoning has changed and now you can build research in some commercial zones, there might be limitations to where you can go on the street. That may be more valuable retail, but that's where the rooftop, you're seeing a lot more rooftop amenities as well. And I think it's critical, any space that you do in life science, a level of collaboration is really key to future research. So I would say yes.
And then finally, what is your strategy in sizing IDF and MDF rooms to support all the data the equipment generate and to support a tenant who might be doing computational sciences?
Maybe I'll grab that one. So from a base infrastructure point of view, we'd likely want to keep it to allow for the adequate risers to be installed. But if the tenant is actually doing sensitive research, that space should be built into their own tenant space to allow from a privacy perspective and also accessibility perspective, and avoid multi-tenants getting into that space. So we would suggest that being in the tenant space.
Great. We've got a couple more questions, but I want to move on to the next panel to make sure that we have time for everyone to contribute. So our next panel is going to address getting to cost and schedule certainty. Brian Northrup will moderate and lead a discussion on that.
All right, thank you, Nancy. And thank you for having me. I'm excited to be here today and moderate this piece of the discussion. Again, just to introduce myself, I'm Brian Northrup. I'm Executive Vice President, General Manager with Skanska. I oversee our construction operations in New England, but I also serve nationally to provide executive leadership for our science and technology group. Like my other panelists here to quickly introduce themselves, we can start with Karen, please.
Sure. Hi, I'm Karen Heidelberger. I'm with Deerfield Management. I'm our Chief Partnership and Communications Officer. And for the past year and a half or so, I've been working on the CURE, which is the innovation hub that we're creating on Park Avenue South between 25th and 26th Street.
Great. Thank you, Karen. Ray, would you like to introduce yourself, please?
Sure. My name is Ray Moore, and I'm a quality research and training specialist with Safety Partners. And for the past 3 years, I have worked with, lab and life science companies in New York City to help develop and implement their environmental health and safety programs.
All right. Thank you, Ray. And then, John, I know you spoke, but if you briefly want to just reintroduce yourself.
Sure, just in case you forgot my name, John Tamburino. I'm Vice President of Pre-Construction for Skanska, New York.
All right, thank you. So, John, we'll start with you. Your white paper on the cost considerations for a lab and research space speaks about the complexities and the cost for constructing a lab space. But from your perspective, when end users, developers, designers, and contractors are working together at the early stages of a project, what are the critical parameters the team should identify early to provide comprehensive budget for the project before the design advances too far?
Sure, I'll speak through the lens of a cost estimator for this. Dan has mentioned it, as well as numerous other people in the panels have mentioned the collaboration aspects of that. You need to have collaboration right up front so that everybody understands what's going on with the program, the equipment, and the lab benches and equipment as well. So that's number one, collaboration. Number two, understanding the program and making sure that we have that information on the drawings earlier on. Also, I like to think that that certain things are in place by the time we start doing estimating, as well as getting involved with some design assist vendors and contractors going forward, especially on the major pieces of the work, like mechanical.
Okay, thanks, John. Ray, just changing over to you, can you tell us a little more about Safety Partners and how you engage early in a project to assist clients on lab projects?
Sure, absolutely. So Safety Partners has been working with lab companies for over 25 years to develop and implement customized full circle EH&S programs so that the companies are compliant with all sorts of regulations and permits, and also so they can help protect their employees and the environment and general public. So we like to get involved with companies early on so that we can make sure that even from the floor plan, everything is in place so that they can work with the materials they need to work with safely, right? And I think from that perspective as well, having really good, as John mentioned and Dan mentioned, good collaboration between the architects and people that are helping build their facility and the building owners and developers are really important as well.
Okay, thanks. And as a follow-up, Ray, what are some of the regulatory issues that can have substantial impacts on a lab development project if not recognized and addressed early in planning?
It's a really good question. I would say from the building owner or developer side, I think it's really important to know what kind of work their tenants will be doing, or what kind of work or what kind of lab companies they want to have move in there, because those companies will have to, depending on the type of work, get permits and make sure that the build out is suitable for the regulations associated with those permits. So for example, even before the first tenant moves in that building, will they be allowed to work with risk group 3 biological agents? Will they be allowed to work with controlled substances, select agents? These all have, various regulations associated with them, whether it be the CDC, the DEA, the Department of Health, right? And so it's good to know before even a tenant moves in, will that work be allowed? And then how do you assess that? So that really requires good communication between that prospective tenant, getting to know, or knowing like what types of chemicals or biological material will they bring in? And aside from something like a fume hood, will they need any additional point source ventilation, mainly because those companies need to make sure that they are protecting their employees from potential chemical exposures as per OSHA? And then would they require any sort of separate room or containment? Because sometimes some agents require that type of separate restricted access room, to be in compliance with, various regulators like the DEA for controlled substances, for example. I would say, again, collaboration and really good communication between, the architect, the company, environment, EH&S consultants are really key to this, because really at the end of the day, when a company moves in, they want as few barriers as possible to, get in, move their things in and start their work, right? And, they've sort of seen the floor plans, but they're not really as aware of, what are the various New York City fire code regulations, building code regulations, and mechanical code regulations. But those all have to be in place in order for them to work with hazardous materials, especially chemicals, right? And one of their main permits is the FDNY non-production lab unit permit. And the FDNY will be coming in for an inspection, and they're going to make sure, are the walls fire rated? Is the space appropriate in terms of size? And does it have the right fire suppression equipment to store things like flammables, gases, other types of chemicals? Are there eye washes and safety showers put in as per OSHA and fire code compliance and regulations? And so, the company might not be aware of this, but they can't get that permit unless these are all in place. So, they need to make sure, and everyone needs to make sure that everything's in place from the development of the floor plan in that space.
Great. And to tie into what John was speaking about in the collaboration, which you both mentioned, obviously a lot of what you spoke about could be major cost drivers on a project. And we know all of our clients want cost certainty as early as they can in the project. So having those discussions and making sure we've adequately budgeted for those items up front is key for success. So Karen, Deerfield is completing the Cure, a lab innovation building in Midtown Manhattan, which is a redevelopment of an existing office building. Can you discuss Deerfield's decision to develop the Cure in Midtown Manhattan in lieu of a more industrialized section of the city, as well as the benefits and challenges with this location?
Sure, happy to. I think a theme of today is collaboration. And for us, although we do see benefits to some of the more industrialized parts of the city, for us, with collaboration being a major part of how we think healthcare is going to be advanced over the next decade, if not longer, as well as the convergence of healthcare across all different sectors of healthcare, for us, being in a centralized location was something that we thought was absolutely paramount above anything else. So we spent about 3 years looking for the Cure. We called it the Unicorn Project. I have a unicorn sitting on my desk because we almost didn't think it was possible to find this building. But this building is built for a tank. It is actually connected to the armory. So I am not kidding when I say it's built for a tank. But for us, it was really about finding a location where we were going to be able to bring in people from all areas of Manhattan. And, the academic institutions were very important, but so are business leaders as well. And for us, being able to be in a central location where we're able to bring in all of those people was incredibly important. The plans for the Cure are not just around the residents that will be in the building, but also really activating the entire community of New York. And it's much more difficult to do that in a different borough or being on the outskirts of Manhattan. So for us, this location was incredibly important. That's not to say that there haven't been challenges. We are lucky that we are zoned for labs here. Having said that, there are restaurants in the area. So as we're airlifting the air scrubbers up to the roof, there are certain restrictions that we have to go through to make sure that we can do that in an area that's also zoned for residential. And that's fine for us being in the central location. It's worth going through that, but it absolutely has made things, we just need to be much more mindful of the community in which we're living, because it's not a complete manufacturing zone around us. I think some of the benefits, as I said, really are the location and the fact that we can bring in many people around us. So I would just say that there are some considerations that we have to be mindful of the community that we're living within here. But we're really excited to be in this community. And I think that ultimately that in the long run is going to be really beneficial for all the residents within the building, as well as the community at large in the area.
Great, thank you, Karen. John, just back to you. As the old saying goes, time is money. So research space is often needed quickly as companies race to develop and move products to market. What are some of the key elements to delivering the construction phase of a lab project as quickly as possible?
Again, speaking through a lens of a cost estimator. One of the things that we look at to bring speed to market is permitting. I think Gus Mazza talked a little bit about that today, about the permitting issues involved around a lab building. So that's one aspect of it. The other thing is the prefabrication of the equipment. Dan and his team mentioned that already about prefabrication of major equipment, mechanical and electrical things as required. And then the last thing is procurement strategies for us. Early packaging with major vendors, either through design assist or other contractors, getting them involved, it will help us get us to the street faster and with a number that everybody can live with. And I'm sure you got some input to put on from the operational side of the fence on this.
Yeah, I mean, obviously, prefabrication plays a big piece in life science work and has for a number of years. I think, trying to get the team comfortable on equipment selections for major equipment, whether it's lab or mechanical, electrical equipment, to release those before the drawings are 100% complete is a key. Mostly, we have the supply chain disruptions that were spoken about a little bit earlier, that we're seeing longer than we've ever seen before lead times on lab mechanical equipment and some of the piping systems for the building. So those are all key drivers that we like to see. And then, there was a question earlier about design build, but design assist is also a method that we use to allow some of the mechanical coordination, other coordination around the lab space to happen while design's still being completed. That just helps shorten the overall timeline to get a building to market quicker. So thank you for that, John. Ray, just a couple questions for you. Karen spoke about her project in Midtown Manhattan. Are there greater challenges when you go to develop a life science building in a highly densified urban environment than in the suburbs?
That's a really good question as well. So I would say that regardless of where a lab company is located, there needs to be, a comprehensive EH&S program, right? And something that really speaks to all the regulations and permits related to it. However, I will say that in a dense urban area, time and planning are of the essence. So really having really well laid out mitigation strategies and procedures that are constantly being evaluated are really important. And take, for example, a chemical spill, right? you really have to make sure you have emergency procedures established well beforehand, that this has been communicated to everybody, that the building itself has really good emergency procedures that take into account the potential for some type